Hi, I'm Tally Modes, and today I will be discussing Lab 3 of Physics 2212 titled Magnetic Field of Permanent Dipole Magnets. In this lab, I measured the distance dependence of the magnetic field due to a small bar magnet and compared my measurements to the distance dependence predicted by the equations for the on and the off-axis magnetic fields derived from the Biot-Savart law. Important physics principles for this lab were distance dependence, the Biot-Savart law for magnetic field of a bar magnet, and superposition of magnetic fields on and off axis. At the end of this lab, I got that mu was 2.925. To set up the lab, I first had to rotate the magnet until the x component went to 0, and then I put a ruler along the bottom of the phone. This represented the east-west axis. I then checked to see if the net magnetic field was correct for my location. In Gainesville, Georgia, it is supposed to be 48 microtesla. This simple check allows you to see if the magnetometer is working correctly. Finally, I placed the bar magnet at the end of the ruler. The next step was to find where the magnetic chip was located inside of the phone. This was the point that all values were measured from for the remainder of the lab. To find the horizontal component, I found where x was at its max and where the y was at its min, and I placed a piece of tape. To find the vertical component, I found where x was at its min and where y was at its max. I placed a piece of tape here as well. The chip is located at the upper edge of where these two tapes intersected, as shown in the picture here. The next step was the calculations. The magnitude of the magnetic field due to a bar magnet falls off as an observation location is moved farther from the bar magnet. The distance dependence can be expressed by the following equation. The magnitude of the magnetic field of the bar equals kr to the n, where k is a combination of constants and parameters such as magnetic moment, which did not change during the experiment. By measuring the magnitude of B bar at different distances from the bar magnet, I was able to determine a value for n. The next step was data collection. I measured the distance from the bar magnet at Bx equals 20, 70, 120, 170, and 220 microtesla. I did 3 trials of each value and averaged them. I then made a logarithmic plot of the data. I did all of this in Excel. Next, I took the natural log of both sides of the earlier equation. At this point, n was a constant, as was k, so I was able to plot ln of r versus the ln of bx to find n, where n was the slope and k was the y-intercept. My work is shown here. I then found the distances at which the net magnetic field was 100 microtesla. This was d-perp. I placed the phone at this distance from the magnet in the x and y directions and recorded the magnetic components, the x, y, and z, at this distance. I used these values for the off and the on-axis magnetic fields in my code. I coded an equation to find the magnetic field using the Biot-Savart law. Here you can also see the result of this code, where the orange arrow is the on-axis magnetic field, the blue are the off-axis magnetic field, and the magenta are the 45 degrees from axis arrows. The diagram at the bottom gives one a good idea of what I mean when I talk about these arrows. In conclusion, I found that when the magnetometer is far away from the magnet, it measures a near zero magnetic field in the x direction. I also found that as the magnetometer moves closer to the magnet, the x component of the magnetic field increases. To wrap up, I looked at 2 questions, the first being, what if you hadn't oriented your experiment to compensate for magnetic north and instead laid out your meter stick at some intermediate angle with respect to Earth's magnetic field? How would your results have changed? The answer is that the y component would be wrong, so I would have to make corrections in my calculations. The second question is, what if you were to stick 2 identical magnets together end to end and run the experiment again? How would you expect your measurements to differ? The answer is, the magnitude of the net magnetic field would double.